Hi, I'm Ed Statham. I'm the Associate Program Manager for Orbiter Operations with Boeing. I want to talk for a moment about drawing systems and how to manage configuration and in your planning sequences. In theory, the new programs will differ greatly from shuttle in that you've got great new tools, so theoretically none of the issues that we had on shuttle would pertain to the newer programs. I'm not sure that's true. It's probably worth repeating some of the lessons learned to make sure that even with the new tools, we don't repeat some of the same mistakes. In essence, it came down to managing the as-built configuration. With shuttle, this was done when we had deviations to a as-designed situation. We would document those via a material review or an MR. So the MR would be dispositioned such that the original design intent was maintained, but it didn't match physically the as-designed configuration. An example of an MR might be if you had a part that broke off and you reconnected those parts via welding. The intent was that you had a solid piece in the as-designed, and now I have joined these two pieces together and once again formed a solid part, but now we did it via welding. The design intent may still be met, but it doesn't match the drawing, so you would do an MR. Problem comes in if that isn't brought into the drawing system where it's readily accessible. You have issues with determining the exact configuration if you're doing a failure analysis or if you're trying to assess multiple MRs in a given location. You might have one MR that is acceptable and have another very similar MR in close proximity, and now it's no longer an acceptable condition. So you really want to be able to access those quickly within the drawing system so that you can evaluate them in their entirety. The second key issue came in engineering working off of the as-designed database and doing future designs as opposed to dealing with the as-built configuration. When we would get ready to do major mods, and I'm assuming that you would have modifications, probably more than one, to a given design, there is the assumption that these proceed in a certain chronological order because designs tend to build on top of each other. When we'd go into major mod, occasionally we would be surprised when we would go to install a mod kit and find out that the attach point did not exist because the prior modification had been deferred. Typically, these deferrals were schedule driven. You would end up establishing a higher priority on the later mod, but you couldn't install it because the part may not have been fabricated from the prior mod. It's embarrassing to go install something and you find out that it doesn't exist. Then you scramble for the parts. You would have to go see if the mod kit was in fact ever fabricated, and can you then break up that mod kit to obtain the part you need to install the later mod. The moment you inject program decision points into the release cycle, you inject that kind of risk. Because they'll decide to do this one, not that one, not understanding that the designs are intermeshed. So it's really important that you maintain an as-built database that's accurate and that your as-designed be verified against the as-built and probably released via a change order before you'd actually incorporate it into the new design. Hi, I'm Ed Statham. I'm the Associate Program Manager for Orbiter Operations with Boeing. The recommendation I would have in terms of drawing systems, and this will interface with whatever planning documentation you're going to use to actually do assembly, is that you maintain tightly your as-built configuration. Any deviations, such as MRs, would be reflected in the as-built. and that you carefully control changes to that as-built configuration and not allow your designers to go design off the as-designed and bring that in, go try to add that to the as-built configuration. You need to check the as-designed against the as-built to maintain that no changes have occurred that would preclude you from making the change that you're fixing to bring into the as-built configuration. There is another option, by the way, and that is if you go have an as-designed change that gets released and you decide to defer the implementation, you can always back out the engineering. No one ever wants to spend the money to do that because they're convinced that they can then install it downstream. And you would have to then re-release the drawings that you just backed out. So cost tends to preclude them from keeping it current that way. By closely maintaining your as-built configuration and by checking your as-designed against that as-built configuration before you include the new engineering into the planning, you will avoid unnecessary surprises, schedule delays, and costs by understanding completely what's required to go do a job prior to beginning.